In Singapore, we have our very own National Water Agency, namely the PUB, that protects Singapore's coastlines from rising sea levels and coastal hazards. So for the last talk of the day, before we move on to the panel discussion, may I invite Ms. Hazel Khoo, the Director of the Coastal Protection Department in PUB, who will be sharing about Singapore's coastal protection measures. So Ms. Hazel Khoo is leading the whole of nation efforts to safeguard Singapore from the threats of sea level rise. Her team formulates policies, develops strategies and guidelines, and sets design standards to guide adaptation planning and implementation tailored for Singapore's diverse and urban setting. So without further ado, please, Ms. Khoo.
Good afternoon, and thank you for the opportunity to share with you on Singapore's approach towards coastal protection and flood resilience. Climate change will impact us greatly, and global temperature has been increasing and sea level rise has been rising. Yet these effects will only continue to worsen. As you have heard this morning from my colleague from CCRS, the latest results from the third National Climate Change Study indicates that mean sea level around Singapore will rise by 1.15 meters by 2100. When coupled with high tides, storm surges, and land subsidence, sea levels could be almost 5 meters above current mean sea levels. Furthermore, we also expect rainfall to increase significantly due to climate change. This is threatening as Singapore is vulnerable to both rising sea levels and more intense rainfall. Singapore is a low-lying island nation with 30% of our land less than 5 meters above mean sea level. We are surrounded by the sea and affected by conditions in the Malacca Straits as well as the South China Sea. Furthermore, Singapore is situated along the tropical rain belt, hence we experience abundant rainfall of around 2,500 millimeters annually, and intense bouts of tropical convective rains are not uncommon. Singapore is already experiencing flooding today along our coastlines. During exceptionally high tides, we have seen flooding in some parts of the East Coast Park areas in recent years. With rising sea levels, such occurrences will become more frequent. Hence, Singapore is committed towards coastal protection. And during our 2019 National Day rally, then Prime Minister Lee Hsien Loong announced that sea level rise is an existential threat and coastal protection would be a national agenda. So in 2020, PUB was appointed as the agency in charge to lead and coordinate whole-of-nation efforts to protect our nation against the threats of sea level rise. As part of our mission, we aim to keep our people safe, protect our assets and infrastructure from damage, and ensure that we can continue to use our land productively in the future. Our strategy for coastal protection is, number one, to build a continuous line of defense to keep out the rising seas. Number two, to provide additional localized protection for critical infrastructure to minimize disruption to our essential services. And number three, to implement a source pathway receptor approach to manage excess stormwater. I will share with you 3 approaches we adopted for coastal protection. I have earlier shared that Singapore is not spared from the effects of climate change and sea level rise, and the V3 study has projected that sea level rise may rise up to 2 meters by 2150 based on the IPCC SSP 585 scenario. While we have set this as our planning horizon for coastal adaptation, the rate of sea level rise hinges largely on the global emission scenarios, and it is difficult to predict today, and hence we are not able to pin down exactly how much sea level will rise. If we build too high too early, it could lead to over-investing, and especially if sea level rise is slower than expected. But if we build too low and too late, then we may end up bearing the consequences of flooding because of inadequate protection. The way for us to get around such climate uncertainties is to adopt a flexible and adaptive approach. What this means is that instead of building our coastal defense structures up to the future 2-meter sea level rise immediately, we identify various options that can be incrementally built or upgraded over time. And when put together, the step interventions form adaptation pathways that are flexible to build our protection against the 2-meter sea level rise progressively. Additional benefits of such an approach include opportunity to explore interventions that may not be available immediately, such as the raising of ground during future redevelopment, or to even tap onto new technologies that may become viable over the years. The adaptive approach, however, calls for the need to monitor observed sea level rise and the latest projections closely so that we can trigger the next course of action when necessary with adequate lead time. Next, in trying to achieve the climate challenge, we approach it as an opportunity to create value through integrated planning. Instead of settling for a functional coastal protection measure that only serves a single purpose and is useful only during an extreme event, we explore multifunctional designs for measures to derive multiple benefits. So examples include deploying hybrid solutions such as mangrove rock revertment, so that as we protect our coastal areas from erosion, we enhance biodiversity along these coastal zones and preserve the natural coastlines. We could also integrate coastal protection with other uses, like creating new recreational and community spaces, as well as to augment new freshwater supply sources. And this is exactly what we have done at the Marina Barrage, and I welcome you to visit the 3-in-1 facility if you have the time. One of the most recent concepts we have developed is the Long Island scheme off the southeast coast of Singapore, mentioned by my minister this morning. The southeastern area is particularly low-lying and is already susceptible to flooding today. The Long Island will be reclaimed off the east coast to form a barrier to protect the existing low-lying areas. And at the same time, it is an integrated solution that meets multiple national needs like water resilience with the creation of a new freshwater body, future land needs twice the size of Marina Bay, and new opportunities with the addition of around 20 kilometers of new coastal and reservoir parks. As coastal protection is a long-term undertaking and requires significant investment, we need to adopt a phased implementation approach in order to make our efforts sustainable. Our coastlines have been segmented into 8 hydraulically distinct adaptation planning areas, and we intend to carry out site-specific studies for each area progressively to develop integrated and adaptive plans. The coastal protection measures will also be implemented in phases to ensure adequate resourcing. While PUB is leading and coordinating the whole-of-nation efforts in coastal protection, it is clear that the government cannot do it alone. Our strategy to achieving shared stewardship is to create awareness on the impact of rising sea level and to educate the public on the challenges and opportunities for coastal protection. We need to engage the community for ideas to co-create solutions, as well as to acknowledge the trade-offs that comes with every intervention. Last but not least, structural measures can only mitigate flood risks to a certain extent. Hence, it is important for us to help the community embrace their roles through building community resilience so that they can take necessary actions during emergencies. Next, we need to build capability through research and development, since coastal protection is a new focus area in Singapore. We have therefore launched a $125 million coastal protection and flood management research program to build local R&D capabilities to drive the development of smart, effective, and solutions and to foster industry collaboration. The research program has been organized into 3 cross-cutting horizontals focusing on closing knowledge gaps and 4 verticals that focus on solutioning. So for example, extensive studies are being conducted under Horizontal 1 on coastal science research to understand extremities and changes in coastal processes affected by climate change. Under Horizontal 2 on digitalization of the coastal environment, research is also being conducted to strengthen the reliability and intelligence of monitoring and predictability of our complex hydrodynamic environment. This is done in collaboration with the Center of Excellence set up in the National University of Singapore, the Coastal Protection and Flood Resilience Institute, Singapore, and I'm happy to know that the Executive Director, Professor Adrian Law, is in the audience today. So the research work that we undertake would help to support the various work streams for coastal protection, including planning and monitoring. Finally, holistic risk assessment from the combined effects of extreme sea levels and intense rainfall is enabled by the development of the Coastal Inland Flood Model, or CIFM in short. The CIFM allows continuous review of flood risks, based on the latest available climate data, and provides predictive capability of flooding events. Despite our coastal protection efforts, structural interventions cannot eliminate all flood risks, and therefore the forecasting capability of the CIFM is critical. The CIFM is a fit-for-purpose application which can forecast coastal storm surge and predict the combined coastal and inland flood events holistically. It will also serve as a tool to help evaluate the effectiveness of coastal protection measures under the adaptive planning approach. Essentially, the CIFM encompasses a suite of tools to forecast inland and coastal floods to provide early warning, support scenario planning, enable spatial planning, and for engineering design. I will now show you a video on the CIFM.
With the threats of more intense rainfall, sea level rise, and the compounding effects of high tides and storm surges, it is important for us to be able to holistically assess and quantify flood risk at our coastal areas. This is why PUB is developing the Coastal Inland Flood Model, or CIFM for short, which aims to simulate the combined effects of sea level rise and heavy rainfall. A key part of the CIFM is coastal forecasting, which enables us to predict and monitor impending storm surge events. This would allow us to provide early warnings and coordinate efforts to deploy emergency response teams. How does CIFM work? To simulate coastal forecasting events, the coastal model of CIFM relies on data from global forecasts, from which a regional dataset is extracted for Singapore's context. Two key datasets are extracted: forecasted wind data and forecasted atmospheric pressure data of the South China Sea region. The extracted data is then processed and input into the coastal model. Finally, the result is the predicted water levels around the coastline of Singapore, forecasted up to 3 days in advance. PUB is currently pilot testing and carrying out post-event analysis and validation for the coastal forecasting model. In the next step of CIFM development, the coastal forecasting model will be integrated with inland flood simulation models to assess the combined flood risks from extreme coastal conditions and intense rainfall. When completed, CIFM aims to serve as a tool to support flood operations and emergency response planning by enabling the deployment of emergency response teams to potential flooding locations ahead of time. It could also be used to inform operations of coastal protection structures, such as the early closure of tidal gates or coastal barriers before impending events. The CIFM plays an integral role in ensuring Singapore is prepared for climate change and rising sea levels, so we can take steps to safeguard our coastal areas. By taking a proactive approach, the CIFM would truly contribute to Singapore's long-term planning.
So as we continue to develop the CIFM suite of tools, we will require quality and continuous data sets and advance our knowledge in coastal processes. Data is a key enabler to support data-driven decision-making for coastal resilience, and efforts will continue to close these gaps, these data and knowledge gaps. Outcomes from the ongoing R&D projects on the interdependencies and joint probability of extreme events such as the wave and current data parameters will be fed into the CIFM database. There is opportunity to augment regional cooperation in the sharing of regional data and coordinate our data acquisition efforts. Sharing of knowledge and approaches at platforms like this could also enhance our collective capacity to deal with sea level rise challenges. To sum up, rising sea levels pose a threat to Singapore and many coastal cities in the region as well as around the world. Singapore is vested in mitigating the risk of sea level rise and will turn our challenges into opportunities to create added value from a multifunctional approach. We will bring the community on board with us on this journey and sustain our efforts through a phased program and with parallel initiatives to build capacity through R&D. All in all, our efforts will be supported by the Coastal Inland Flood Model, serving as the central nervous system. We welcome collaborations on various fronts for a more sustainable way forward for coastal resilience and management. With this, I thank you for your attention.
Thank you, Ms. Khoo. So, any questions from the room? If not, I think there's one. Great.
Very impressive. And I would like to know about the astronomical time. I never seen you put in the model. Normally we have the meteorological time, that means wind and pressure, right? And how about the astronomical time you add on? How do you add on that? Thank you.
So I think there are different components of the astronomical tide, and for Singapore, we experience about a 3 to 3.5 meters tidal range. And you are absolutely right that when we look at the total sea level rise, we look at tide levels compounded with coastal surge, as well as mean sea level rise and land subsidence to achieve the relative sea level rise. And that is what we base on for our planning parameter. I hope I have answered your question.
Thank you. We have also one question on Pigeonhole about saltwater intrusion into reservoirs. Is there an issue in Singapore? If you can say a word or two.
It is not an issue today, but we anticipate that with sea level rise, that saltwater intrusion will indeed be a risk to our freshwater supply resources. So we are looking at the thresholds to which we protect and raise the dikes of our coastal reservoirs, especially those that are, at the coastal areas, so that we can limit the risk of seawater intrusion. I think we are also looking at with a higher head as a result of the higher sea level rise versus the reservoir water level, what will be the saltwater seepage into the reservoir. So these are studies that are ongoing, and indeed this is an area that we are critically concerned with, because we are also concerned about water resilience on a whole.
Okay, thank you, Ms. Khoo. Very interesting talk.